All right, we are going. So, good morning. I'm going to share my screen with you guys. A couple things I need for you to see. So, good news and bad news. The good news is our textbook got even better. The bad news is, and you don't have to do much, but I'm going to show you this real quick. The layout has changed just a little bit. So this is probably what it's going to look like for you guys. Notice you have an assignment today, homework number 1. So you guys can do that. I also want to point out it is only 3 questions. I'm not sure where we see that. Sorry, they just changed this all up on us literally this morning. So there should be a way for us to see that, but you guys can do this. It is due at 8:30 a.m. tomorrow. I'm going to go ahead and tell you guys this one assignment, this is the first assignment, and this is really the only one that is not going to be, it's not going to be worth points because this is brand new. They literally at about 8 a.m. They just changed what our book looks like and how we assign stuff. So I gave you guys, it's not a fake assignment, but it is going to be very easy. So there's 3 questions. I want to make sure that A, I assigned it right, and B, you guys can log in, you can save it, and you can submit it, okay? There might be some glitches, so that's why I'm starting with one that's not worth points, but I still want you guys all to do it. It should not even take you more than 2 or 3 minutes, literally. So that is the first thing I want to show you. Back to the assignments. If you guys are up here, your assignments will almost always be in 2 places. I haven't put it up here yet, but you can go to assignments and see what it is. The first place I would do, I would go to every single day when you get up, is go to this. You guys can see what your assignment is and what we'll be using. Now, these are just extra if we have a few minutes, but if you want to go ahead and click the PDF, you can open up the PDF on there, preview it, whatever you want to do. This is what we're going to be going over today. So take a second, download that, pull it up. There's your assignment. Just showing you guys again where you'll see everything, how to get acclimated. One last thing I'm going to show you guys. I know we've discussed it several times. I'm going to show you for the third and probably last time is if you go to current lessons, your YouTube video for today is going to be up here for Monday, August 3rd. So current lessons are where you will find that. Now, let me go ahead and minimize. Let's bring this up. All right. So whenever we do this, and remember, I asked you guys to have a graphing calculator that you do not need until Wednesday, but on Wednesday, you will absolutely need this. You might have one on your computer. Hopefully it works exactly the same. I'm going to ask that you guys have a notebook next to you so that you can do some of this with while we're going over it. You don't need to write any of this down. This is for both of us and just so we can keep organized. I don't know why I wrote 1-3. Sorry. I can go ahead and change that. It is 8-3. There we go. So we're talking about transformations of functions. Your objective is up here. SWBAT means students will be able to, by the end of today, I just want you to describe and graph the transformation of linear and absolute value functions. So let's go ahead and get started. I'm going to say something else here real quick. Some of this seems really basic. In fact, I'm going to look at you guys here real quick. Some of this stuff seems really basic. We are starting off super slow. We're eventually going to get faster and faster and faster. If I ask you to write something down, it's probably best to write it down. And any practice problems, make sure that you guys are actually trying to practice problems. Remember, as of right now, as of today, 100% of your grade is homework, which is going to be starting tomorrow. So it's really on you guys to make sure you understand that. Let me go back up to share screen. And where did it go? There it is. All right. So the whole concept here, and I am going to go pretty quick with this one, but the whole concept here is we're talking about graphing. Well, what I have on this page are 2 parent functions. So a parent function means It's the most basic stripped down version of this function that we have. So y equals x is the parent function for something that would be like y equals 3x minus 5. So this is the parent function. This is a transformation of the parent function. So y equals the absolute value of x is a parent function. And what would be a transformation would be something like y equals 2 times the absolute value of x minus 1 plus 3. And what a parent function means is it has the same basic shape, same properties. It's just been stretched, shrunk, reflected, or moved across the graph, and that's it. Now, in general, and I know it's been a long time since you guys have probably done anything like this. So if I'm going too slow, I apologize. But if you ever forget how to graph, you can just make a table. That's all you have to do. Remember, your x's are always your inputs. So I'm going to go ahead and write that up here again. Your x's are always your inputs. And the good news is you can input any value you want. The y is your output. So your y depends on what you put in for the input, which makes your x your independent variable and your y is dependent. Your output depends on what you put in. You can pick absolutely anything for your x's on any time that you're graphing. If you ever forget, pick anything. Pick some negatives, some zero, or pick some negatives, zero, some positives, whatever. So I could do something like -3. I could pick -1. I could pick 0, and let's just pick like 4. I chose them completely at random. It doesn't matter. But once you do that, I'm going to go ahead and change color here. I can choose anything for my x's. So when x is -3, when you plug it in, well, if x is -3, then that just makes y -3. Pretty simple. If x was -1, y is -1, x is 0, y is 0, 4, and then plot the points. So I'm at -3, -3, -1, 1, 0, 0, and 1, 2, 3, 4, 1, 2, 3, 4. There you go. One big reminder is make sure that your graph takes up the entire graph that you're drawing. Like I said, bear with me here. This is awkward to do. That should be a straight line, but your graph should take up the entire graph there. All right. Next one, and it goes on forever, so it should have arrows at the end. Same thing, let's look at the absolute values. A quick reminder, an absolute value is counting steps, so the absolute value is the distance away from the origin. So if I take 2 steps forward, it disregards or discounts direction and just says I took 2 steps. So if I took 2 steps backwards, I still took 2 steps. So absolute value, what it really does, it acts like a car wash, and it always comes out clean or positive. So what that means is if I chose those same values, if I chose like -3, -1, 0, and 4, I plug this in, and then the absolute value is an operation, and it cleans it. So the absolute value of -3 is +3. The absolute value of -1 is +1. Absolute value of 0 is 0. And the absolute value of +4 is +4. Again, I don't know if I just said this, but it's kind of like a car wash. If I take a dirty car through a car wash, it comes out clean. If I take a clean car through a car wash, it comes out clean. So absolute values always come out to be positive, but be careful. If I had something like this and I'm plugging in -4, let me just show you. You do the operations first. So -4 minus 1 is -5. But then I take the absolute value of -5 before I do anything else, okay? To show you what the parent function looks like, let's go ahead and graph this. When x is -3, y is +1, 2, 3. -1 is +1, 0, 0, and then 4, 4. Let's see if I can make that a little more straight. There we go. So that's your parent function of what an absolute value looks like. Now I'm going to pause here real quick. Any questions at all? Okay. So let's go on. And again, I'm going to go back here real quick. Our objective here was to be able to describe and graph the transformation of linear and absolute value functions. So far, all we've done are parent functions. So a transformation means it's going to keep the same basic shape. It's just going to shift it, reflect it, or make it more steep, stretch it, or compress it. So let's see what we have here. Now, if I have something like this, again, I can choose absolutely any values for x that I want. I want to make sure that I'm putting some negatives and some positives up here. But I also see this value here as I've got a -2. We'll come back and talk about this here in a minute, but I want to make sure that I always do the opposite. I want to come back and find a way to get 0 here. So I'm going to start with like -3 again. Then I'm going to go to 0. Then I'm going to go to +2. And then I'm going to go to 4. Again, I just chose those at random. So when x is -3, again, these are inputs. I plug it in and I see what the outcome is. So if I plug in -3, I have -3 minus 2 and the absolute value. -3 minus 2 is -5, but the absolute value of -5 is just 5. Oops. There we go. Next one, if I plug in 0, I have 0 minus 2, which is -2. The absolute value is +2. 2 minus 2 is 0. We'll talk about that here in just a minute. And then 4 minus 2 is 2. Absolute value is 2. Let's plot these real quick. So I've got -3, 1, 2, 3, 4, 5. Did I do that right? Yeah. I've got 0, 2. I have 2, 0. And I've got 4, 2. Again, I could make as many points as these as I want. I need at least 3. But if I go ahead and draw this out, draw my So I would like a volunteer here just because I need a little interaction. You guys are probably getting bored. So how would you describe this transformation? Remember, if your parent function looks like this in the blue, what's the difference between this one in the blue and this one? The only difference, how has this been moved? Will somebody unmute, be a risk taker, and tell me?
It's x plus 2. Like,
So you said x plus, just tell me, how has this moved? Has it moved up, down, left, or right?
right.
That's
Right.
it. So good job, Gabe. It's just moved right to. It's the exact same drawing, same quote unquote slope. We'll talk about the concept of slope here in just a minute, but it's just moved right to. Well, let's look at this, the difference between what's happening inside the absolute values and what's happening on the outside of the absolute values. So if I come back up here, I'm going to change it to red. I'm going to use these exact same inputs here just for consistency so you can see what's happening. So if I use -3, 0, 2, and 4, I'm going to go kind of quick with this. So absolute values make them all positive. So that's going to be 3 minus 2, 0 minus 2, 2 minus 2, and 4 minus 2. So let's see what that looks like. So if I've got -1, 2, 3, 1, I've got 0, -2, I've got 2, 0, and then I've got 4, 2. Did I do that correct? Oh, that's why. Sorry. Put that at the wrong spot. That was -3. That looks better. All right, so if it happens outside, if I've got something going on outside, a plus or minus outside, how is that shifted from the parent function? Somebody else be a risk taker here and ask or and answer that, please.
It goes up or down.
That's exactly right. And again, we're using this today. I know that a lot of this is review. We're just using this to kind of get some rhythm to the classroom. So if it's on the inside, it's just moving it left to right. And if it's on the outside, it's just moving it up or down. So let's look at this one. Well, what happens if we have a coefficient? I notice I've got a positive one, a negative one, and a fraction. So what that's going to do? By the way, does anybody, what do you think that that's going to do? And maybe you remember, but what do you think this 3 right here is going to do to the parent function?
It's going to change the slope of the angle of the.
Say that again.
It's going to change the slope.
Right, it's going to change the slope. And remember, it's not truly a slope because slope suggests constant change. It is constant, but from the vertex, which we'll talk about in a minute. So if it's positive like this, and if it's greater than 1, it's really just going to make it more steep, or it's going to stretch this. So again, I can pick any values here, and I'll just pick some simple ones like -2, 0, 1, and 2. So plug them in. Absolute value of -2 is 2 times 3 is 6. 0 times anything is 0. That's going to be 3, and that's going to be 6. So you can notice from the parent function, -2, 1, 2, 3, 4, 5, 6. 0, 0, 1, 3, 2, 6. So it's the same basic shape, but our slope, or the rise of run, it's going to be much more steep. Now, again, I've talked about this a couple times, but where the graph turns is called the vertex. Absolute values make V's. So all that the coefficient, if you will, does, all that this value does, it does one of 3 things. It either stretches it or makes it more steep. It shrinks it or makes it more compressed. By shrinking it, it kind of looks weird. But a shrink would be something like this. It's a lot wider. Oh. Let me switch to blue here and let's do this. If it's negative, what do you think a negative is going to do?
It's going to flip it upside down.
That's exactly right. It just reflects it about the x-axis or flips it upside down. So again, same thing. Absolute value of -2 is positive 2 times -3 is -6. We've got 0, -3, and -6. So if we compare these, if it's negative, it's literally just going to flip it over the x-axis. So I'm going to do this real quick. I think that's about 6. 0, 1, -3, 2, -6. So again, that is a reflection over the x-axis. Now, I do want you to tell me over the x-axis because tomorrow we're actually going to talk about a reflection over the y-axis and what that looks like. But right now, I just want to kind of get this all down. Last one, if you ever have a fraction here that is less than 1. Notice a 3/2 is not less than 1, so that would still be a stretch, not a compression. But if I ever have a fraction less than 1, that's what's going to make it a compression or a shrink. By the way, what values do you think would be easiest for me to plug in for x? Somebody unmute yourself and tell me, what values should I use for my inputs here? Not sure?
Like multiples of 4.
That's exactly right. So multiples of 4. So I'll do like -8, -4. I always want to put 0 in if I can, and 4. And that way I don't have to deal with any fractions or decimals or anything like that. So the absolute value of -8 is 8. 8 times 1/4 is 2. Absolute value of -4 is 4 times 1/4 is 1. 0 is 0, and that's going to give me 1. So -8 is way over here. -8, +2. Then we've got -1, 2, 3, 4, 1. We've got 0, 0, then 1, 2, 3, 4, 1. So now you guys kind of have an idea of what a stretch and a shrink look like? Okay. Any questions so far? All right. Let's move on. And this would be one time that I'm going to give you guys about 2 or 3 minutes to write this down. You absolutely don't have to write down everything, but this is kind of the heart of the lesson. Tomorrow, we'll also throw in reflections over the y-axis, but get this part down first. So take a couple minutes, write this down. So I don't love the way I described the vertical stretch or shrink, but if I put it into words, I think it would be even more into the actual, the perfect words. It would be very verbose, very wordy. So make sure you guys pay attention while I'm explaining that. I'm gonna give about 1 more minute. Again, that might be too much time for some of you guys and might be a little fast for others. Remember, this is up on the PDF if you've got that pulled up. But just so you've got it right by your side while you're doing the homework.
Under vertical stretch slash shrink, it says like if A is stretched by a factor of A, and then it just like ends. What is that?
Right. So so A is the coefficient there. So whatever's there, and yeah, that makes sense.
Oh,
If
okay.
if whatever's there is greater than 1, it's stretched. Yeah, I would say, for instance, if that was a 2, I would say that my graph has been stretched by a factor of 2. Good question.
Okay.
And again, just a reminder, I want to make sure that your guys' notes are useful for you. We literally talk about transformations about 5 times in Algebra 2. So the better we learn it this time, the more we write this time, the less we have to write on the back end. So if you learn it really well this time, next time, and this is like a 3-day lesson, next time it'll be a 2-day lesson, and then the last 3 times will just be a remember when we did this kind of thing. So I'm going to go ahead and start going over this. I know some of you guys are still writing, but in general, whenever you have a number outside, so plus or minus to the absolute value, that's always moving it up or down. That's it, and it is what it is. So when it's on the outside, sorry. So when it's on the outside, it's always going to move it up or down. So for instance, I say on the outside, I could have something like this. Doesn't have to be behind it. It just has to be outside of the absolute value. That 2 is still your K value. So in this case, that 2 is positive. So is it going to move it up or down?
Up.
Up. That's exactly right. okay? Now, be careful. I'm going to give you guys a quick be careful because I've seen somebody make this mistake before. If I had y equals 2 minus the absolute value of x, how's the 2 moved it now?
Is it
Anyone?
still up?
Yeah, it's still up. And then what's this minus do then?
It makes x negative.
Or it just reflects it, right? So in other words, while this is really confusing, what you might run into, this is saying the same thing as this, the opposite of the absolute value of x plus 2. These two are the exact same thing. The top is confusing, the bottom one makes sense. So it's been shifted up 2 and reflected over the x-axis. So let's move on. I'll change color here real quick. I realize that green might be hard on your guys' eyes. So if it's ever happening to x, in this case, if it's in the absolute value, it's always going to really be the opposite of what's going on. So if I have the absolute value of x plus 2, it's really shifting it left 2. If I had the absolute value of x minus 2, it's really shifting it right 2. Now, I think that's pretty self-explanatory. We'll get to that in a minute. Now, here's where I want to make sure you guys, I don't love how I wrote this. I will let you guys know. I could have written it better, but it would have taken up the whole screen. So in general, if a is ever greater than 1, now discount the negative because that means something different. So if a is ever greater than 1, it is stretching it. I don't care if that's a -2 or a +2 or whatever. I'm just looking really at the absolute value of that, which I didn't include in the notes because it gets confusing. So if this value is ever greater than 1, it's stretching it. If it's ever a fraction between 0 and 1, it is shrinking or compressing it. So if I had something like this, y equals 1/5 absolute value of x, that 1/5, and I'll go ahead and make that negative, that 1/5, it's still compressing it or shrinking it. But what this negative does, that is what creates a reflection across the x-axis. Okay? So the negative means something specifically that it's being reflected, but if that value is greater than 1, it's being stretched. If it's in between 0 and 1 or a fraction less than 1, it's been shrunk. Well, let me ask you this question real quick then. So a lot of people just look at fractions. What if I have something like this? That's 4/3 times the absolute value of x. I know that's hard to see. So is that stretched or shrunk?
Is it stretched?
It is stretched. Why?
Because the factor is greater than 1. I mean, the 4/3 is greater than 1.
That's exactly right. That's perfect. So I would say it's stretched by a factor of 4/3. Okay. So a lot of people just see a fraction and they'll say, oh, it's shrunk, but it has to be in between 0 and 1. Okay. I'm going to go ahead and clear that. Now, literally take about 2 or 3 minutes. We're almost finished with the lesson. And I would just want you guys to identify the transformation. So you can just say like up 2, down 2, left 2, right 2, whatever's going on next to each one of these. So I would probably write these out and just at the very least, make sure you understand how you say this. So take 2 or 3 minutes, try that on your own. If you have any questions, feel free to unmute yourself and ask. By the way, while you guys are working, I'm going to go ahead and say, I'm going to try to help you guys and myself. I'm going to try and usually in class about 10 to 15 minutes early. so that we can open it up to questions and I can help you guys more on a one-to-one basis, see who needs help. And I'll stay on until the bell rings. Just you guys can start your homework, you can look at it, and that way you might not need to attend a help session. If there was something you need to see, you can ask questions about it. So again, not trying to rush you, but I'm going to give about 90 more seconds and we're going to start. About 30 seconds. And then I'm going to ask for volunteers to run us through 1 through 6. So think about volunteering here. It'll make it go a little bit quicker. Also, I kind of want to get everybody involved. So I've had about 4 or 5 speakers so far. I'd like to get everybody involved. All right. So very first one, who's a volunteer on number 1? How has this been transformed? And you can just say up, down, left, or right too.
It goes down to.
Perfect. So all you have to do would say, this is shifted. Oh, I forgot the end. This is shifted down 2. What about number 2?
Right 2.
Perfect. Thank you. So again, whenever it's happening inside or with the X directly to the X, it's always going to be the opposite of what you would think. If it's on the outside, it's always going to be affecting the Y, which is up or down. Kind of makes sense. So this is putting it together. So number 3, how would I say number 3?
Left 1, up 3.
Perfect. So left 1, up 3. Well, number 4 has 3 of them. Give me a volunteer for that, please. And I always put this last. So I always start with left to right, then up or down, and then whatever's happening out here. Volunteer?
Is it right 3, up 2, reflected?
That's exactly right. Now, make sure when you say reflected, and that's okay for today, but reflected over x-axis. So tomorrow we're going to have reflections over the y-axis, and I don't want you guys to confuse that. So reflected over the x-axis basically means flip. So understand that. Tomorrow, when we're starting to deal with a reflection of the y-axis, flipped still means upside down. So that's why you guys need to say reflected over which axis. Reflected over the x is fine. All right, we got 2 more real quick. What about number 5? Anyone?
Is it shrinked and left 4, down 1?
Shrunk, that's exactly right. Left 4, down 1. And this one, last one, is just going to be, and I'll just do this real quick. It is going to be stretched. I apologize for the bad handwriting. And this moves it just right 5. Now, just remember on an SAT or ACT or anything formal, we would really say it's stretched by a factor of 2. We would say this is shrunk by a factor of 1/2. Okay, and that's how you say it. Last thing, and we'll pick up on the rest of this tomorrow. So a lot of you guys are curious. Awesome, you got this, real simple. So if those rules work for absolute value, how do they work, or do they also work for linear functions? And they do. Well, here's where the confusion comes in. Y equals x minus 3. So a lot of people would say, okay, so that's moving left 3. Or other people would say, no, it's outside, so it's down 3. I just want to show you guys this. If I made a table, which I could, well, you could make a table. Instead, we know how to graph this. My y-intercept is -3. My slope is +1. So did it move right 3 or did it move down 3? What happened? Well, if you look at that with the linear function, it did both. So saying that it moved right 3 is the exact same thing as saying that it moved down 3. So remember the parent function, I'll change to black here. The parent function was y equals x. Sorry, that's shaky. Which is a straight line like this. So that origin has either moved right 3 or it's moved down 3 without anything else here, without any operator. Well, I don't know if that's on the inside or outside, but it really affects it exactly the same. So if I've got x plus 2, somebody would say, oh, that moves up 2. Somebody might say it moves left 2. You're exactly right in both situations. Let me change it to blue, and this is really the last thing that we're going to do. So x plus 2, my y-intercept is +2, my slope is +1. So you can see it did both. It moved up 2 and it moved left 2. So the exact same rules apply. And somebody's going to say, well, what about a stretch or a shrink? Well, okay. It's a little bit awkward with a linear function here, a linear equation, but I would say that it's been stretched. Well, you can't really stretch a line, but it becomes more steep. So my y-intercept is still +3. I'm going to do it in blue. I apologize. But now it's been stretched up 2 over 1, up 2 over 1. So on and so forth. Okay? So all of the rules still apply. Just to give you guys a heads up, you might want to look at this. Can you do this? We'll pick up from this tomorrow. Remember, you guys have an assignment. We are done for today. Don't worry about the homework. You don't have a book. I forgot to delete that. But let me show you one last time. Well, I might need to stop. Okay. Go ahead and log on. I'm going to stop share. Go ahead to log on to your big ideas. Let me share last time, and then I'll let you guys go. I'll stay on here. So you guys have a big ideas assignment. So 1.1, 3 questions. I'm not sure if I told your class or if it was just the first period class, sorry. But it's 3 questions, and I'm having you guys do this really for 2 reasons. To make sure, A, that you guys got logged on, B, that they just changed the interface, the user interface. So literally just this morning. So I want to make sure that I assigned it correctly and that you guys can do it and submit it correctly. This one is not going in the grade book. Tomorrow's will. But I still want to make sure that you guys have the ability to submit and that I assigned it correctly. Okay? So it shouldn't even be a 5-minute assignment. I meant to leave you guys about 10 minutes of time. We've only got about 3 minutes. For that, I apologize. I'm going to go ahead and stop recording.